Okay, here we're going to look at a basic incline plane force question. Okay. Actually, let's just make that a bit bigger. So you can see the components here. I've got an object of 20 kilos. Now already you can notice that my axes, compared to this one over here, see my axes I can put straight through along the plane and straight through the object there. Here I'm going to keep my x-axis here and y-axis coming right down here. So my normal is actually still in the positive J direction. And then what happens with my mass, my weight force here, that comes down at a perpendicular there. So my weight force now has, look at that and that, an I and J component. So here I've got a 20 kilo mass is held on a smooth, which means it's frictionless plane by a force acting up the plane. So my force is acting that way. So it's holding the object back from going down. Plane is inclined. At 30 degrees. So that's there. Find the magnitude. Of the force, of the applied force. Okay, so we've got a normal force acting on it. Normal force always acts on the object to keep it on the plane. So the plane's here, the inclined plane is here. I've got some G force holding it from slipping down the plane. And then I've got my weight force, which is perpendicular. Here it actually drops down, so he has an I and J component now. And I'm going to split each of these up into individual forces because it's being held on a smooth plane. So we're assuming we're at equilibrium. So the sum of all my forces is equal to 0. Okay, so let's split up my forces. So my N, I don't know what my normal force is. It's not W in this case because W has an I and J component. So that is, I know it's in the J direction. So it's pi J. My G force, I don't know what that is, but he's only working in the positive I direction, so I'm going to call him XI. And then W has an I and J component. Now we've got W, which is mg, so W is still mg. So the magnitude of that is mg, that there. Okay, now you can see here, all I've got, this is my I component and this is my J component. And then this hypotenuse is mg. So let's have a look for our angle. So that's 30, that must be 60. These two are parallel, alternate angles. That's 60 degrees right there. Okay, so if I want to find my I component, I'm just going to do some working on the side here. So my I component I'm going to use cos because I've got adjacent and hypotenuse. So cos theta equals adjacent over hypotenuse. Cos theta equals h cos theta equals a. So then that's mg cos theta equals my I component. Okay, so W will be negative 20 times 9.8 cos 60 I. And then my J component, I'm sure we can take a guess at what that's going to be. So I'm going to use sine. Sine theta equals opposite over hypotenuse. So hypotenuse sine theta equals my opposite side. So my J component side is equal to mg sine 60 in this case. Or sine theta if we want a general case. So I dropped it up there. So again, J negative direction. So I've got negative 20 times 9.8 sine 60 J. Okay, so this object's at rest and we're assuming we're at equilibrium. So what that means is I can determine what my normal force is and what my G-force is. So if we have a look here, if I equate if the sum of all my forces equals 0, that means my I components must add to give 0 and my J components must add to give 0. So if I look at my equations here, I've only got, here's a J component and there's a J component. So I have one unknown there, and here's an I component with an unknown and an I component with not an unknown. So now I can evaluate my forces. So my normal force is actually, let's equate J's. So y plus negative 20 times 9.8 sine 60 equals 0. So y equals 20 times 9.8 sine 60. Y equals, okay, so 169.74. So therefore my normal force is 169.74 in the J direction. And if I just want to find the magnitude, I do the Pythag. So my I component squared, which is 0 squared, which is 0, and then this squared, and then square root. So the square root and the squared cancel each other out. So I have 169.74 newtons. And then if I want to equate my what did I do there? J's I's. X plus minus 20 times 9.8 plus 60 equals 0. So x equals 20 times 9.8 plus 60. So x equals 98. So therefore my G-force is 98I, or the magnitude of my G-force is equal to 98 newtons. So there, that's the magnitude of my applied force in this case. So you can tell here, see this is my only I component, so that there, the negative of that was actually equal to that. My normal force here is, that's a positive J direction. W had a J direction as well. So those two forces actually balance each other out to keep the object in equilibrium. So now you can do a couple of questions.